maybe we could start by having the panelists introduce themselves.
Fair enough. Panelists?
Sure. I'm Beatrice Blanco, and I guess I didn't even talk about myself at all, which everybody else did. So I'm the Senior Manager of Platforms and Applications for the Intelligent Solutions team at Mitsubishi. I've been in this industry for 14 years, either in aerospace or power generation, and my background is a degree in mechanical engineering, but I've really been focused on data analytics since about 2013.
I'm Randall. Hello, can you hear me? I'm Randall McNair. I am a researcher working on a practice-focused book on the area that I did my doctoral dissertation research on, the use cases for investment in digital twins of complex facilities throughout the life cycle of the asset as an informing tool. And one of the things that people ask me, why would I want to come here and represent? I actually spent 34 years in industry, 32 of which at Chevron, doing the technology transformation. And everywhere I went, I was finding some of these same challenges, regardless whether we were moving from mainframe to client server, wherever we were making a major transition, there were opportunities for lessons learned, and how are we actually applying those lessons in a real world case, because a lot of times we just experience our lessons but bury them and never really celebrate them and learn from them. So I'm trying to figure out how we can do that better about that. And this sounds like a really great way to do that.
PJ Kamney, Logan Aluminum. I won't repeat the...
Sean Gregerson, Vice President of Asset Performance with Aviva. And I've been working in the IoT space and AI, machine learning space, and helping many leading industrial operators globally for about 15 years now apply these advanced technologies to get the gains they're looking for in their businesses.
John Grundite, Frito-Lay. I run the fleet for the entire country and help out in Canada. So my main forte is technician training, diagnostics, analytics.
Dominic Lillo, I'm the CEO of Symphony Industrial AI. We have solutions for systems, people, and assets.
And then Zach Novak, I lead the sales team at Uptake.
Okay. So do we have any questions for our panelists here? If not, then I'll begin. So what can you see? Oh, okay. I didn't see.
Hi, John Campbell from AspenTech. Beatrix, I'd like to understand a little bit more about the service model that you guys have. What do you expect the clients on site to be able to do with the software that you've deployed, or are you really advising them? Where's the line drawn there?
Yeah, so because we don't own the assets, most of the way that it works is we provide recommendations, and then it's up to the customer to make the business decision. And in some instances where they don't feel like they want to shut down, then what we do is we can set up models to give them weekly updates, daily updates to see, okay, it's getting worse, it's not getting worse, it's maintained. And so that's really the relationship that we have. Unless we're, certain that there's going to be a catastrophic failure, then that's every issue that we have is a phone call, and then it's just constant communication. But it's really up to the customer to decide how they want to operate.
All right. I have a question for all of you here on the panel. If I'm an organization looking to go about and start my APM journey, where do I start? Do I have to go, set up on a college campus and just hire every data scientist that's out there?
I'll take it. If you hire a data scientist, you will fail. You will fail. These are engineering companies that have to solve engineering problems, number one. And number two, we have customers that, like everyone has to, what's my AI project? So we have customers that have 90 plants. We have customers that have 120 plants. So I have engineering managers, manufacturing, shop floor managers, and they have a budget and they hire 3 data scientists. So what they're missing is 2 things. Number one, they're missing a platform, right? So anyone can pull data out of a PyHistorian. You can do it on Excel, right? You can do that, and I can find some anomalies, right? Every kid out of college with a master's degree in computer science can do that. Number one, you have to have a platform for it. And number two, you have to think about how the hell do you get it to 1,200 facilities, right? One data scientist is not going to do that for you.
Yeah, I have a really good example of that. We had somebody come in and we had them evaluate all of this data to echo the data scientist portion. And the data scientist came back and said, your greatest indicator of a trip is that your load, it was load and speed. Your load is 0 and your speed is 0. And I was like, thank you. That is super accurate and not helpful whatsoever. So if you don't have the engineering context behind what the data is talking to you about, then it's not as useful. So you really do need that engineering expertise and the scalability of a platform.
Yeah, and I would just say that you really need to almost take a step back and really start with your corporate objectives. So what are your corporate objectives? Do you want to improve and meet your ESG goals in a better way? Do you want to improve reliability and profitability of the business? And then map those goals to the asset strategy, because the asset strategy isn't just a single-threaded approach that's based on machine learning and artificial intelligence. It's really a multi-dimensional approach that you start with really understanding your asset strategy, optimizing that asset strategy. It's going to have multiple components to it. It's going to have preventative maintenance that you're going to manage in your enterprise asset management system. That's going to be based more on time-based maintenance than maybe condition-based maintenance. And many people would use that real-time industrial fabric that they've implemented in their business that you might look at a data historian to set up events and alerts that auto-trigger work orders in your enterprise asset management CMMS systems. And then that next layer being predictive, where you're leveraging artificial intelligence and machine learning to drive early warning indication, prescriptive guidance on what action should be taken, and then kind of developing this risk-based maintenance strategy that really ties all this together and applies, whether it be preventative, condition, and or predictive maintenance strategies for the asset based on its complexity and its importance to the business.
Anybody else want to add to that?
I'll add one. I will add just one word of caution. If you do go down the road of bringing a data scientist, I think to the flip side, where there are very few people in the world who understand the data science side and what's possible with machine learning and AI, that also understand the engineering and the physics of these assets. And the thing that I would caution you all to look out for is when you start bringing in data scientists or scaling out these teams, a lot of times their natural instinct is going to be go solve the problem with the hardest possible approach from an analytics perspective. And the reality is 90% of the time, the basic approach gets you the majority of the value. And so I think just as you all are starting to manage data scientists and those teams, just being able to check them and make sure that they're not going down an academic approach just because they like it and actually are driving towards value for you and your business.
I echo most of those. As an aluminum sheet manufacturer, we know about our machines, we know our product, we know what business we want to do. AI models, in none of these artificial intelligence models are build it once and it's done. These platforms are not, just like intelligence, it has to be maintained. It has to learn continuously as processes change. That's a continuous process. What worked for us is we are looking at our business side of it and let our vendor actually monitor, provide monitoring services. We signed up for the monitoring services. So if retraining, every time you change a spare part out of the machine is behaving differently. If it needs retraining, all the technical aspects of artificial intelligence, we leave it to the vendor, and the teams work very closely. We have citizen data scientists who understand enough to communicate with the vendors and the experts on artificial intelligence so they can communicate the business and get the business decisions from the tool.
So one of the strategies that we experienced at Chevron was not so much going out and hiring the data scientists, because one, we couldn't afford to hire a bunch of data scientists because that's a really hot topic right now, trying to bring them in. What we did, which I thought was really smart, was we took some of our best engineers and operators and basically said, here, we've got an opportunity to send you off to MIT, to Rice University, to go sit down and become a data scientist in 9 months and come back, and now you're already a part of it. So it's actually being very intentional about where your future goal is, and building a community of trust is that we're not here to bring technology to replace you. we want you to embrace this idea, this transformation that we're all a part of, and we're going to go to this future state together. So it's really just setting a goal and a vision and getting there together and making sure that you're not just going and cherry picking and having everyone, okay, well, you went to the right school to begin with, so we're going to create a bunch of clones of data scientists to go do operational things. We want people with diverse perspectives, just like Matthew Syed in his book Rebel Ideas. You want to make sure that you're covering the entire spectrum of the unknown unknowns, not just bringing in a bunch of people that know just one thing about one thing.
I think we have a question from the audience.
You all had really good examples of the outcome of the prediction and the insights that you were given. How are you using that back to feed it into the life cycle again? So you had talked about, cylinder head issues, and you keep seeing those. Now, how do you manage that data set that you've created again to go back through and really prevent a lot of those from even being a detected prediction?
So for us, you have to change your mindset. You got to change from reactive to proactive. So let's use a transit as a good example. If you've got the data, and we've got thousands of points of data that shows that an alternator is going to fail on a Ford Transit somewhere before 200,000 miles, you got to break that culture of fix it as it fails. We've got the data out there today that says it's going to fail, so I'm going to go in, I'm going to put a work order in place to change that part out at 180,000 miles. And yes, I may lose some runtime on that, and I may have some that fail prematurely, but if you fit into that 80% category, now I've just got 45 minutes of time for labor and the part. Instead of waiting till it fails, where it locks up, it burns the belt off, it gets into the fan blade goes into the radiator. Now I've got thousands of dollars worth of repairs instead of a $200 alternator and a few minutes of time. I've avoided the tow, I've avoided the rental while it's down, because you all know supply chain problems. We can't get parts for anything today in any great amount of time. So you have to go to predictive and use that to save you the money.
And then I'll just add to that, I think it's a great question, because if we go back, and it really ties to the first question that was asked as well, if we go back a decade ago, it was all about the algorithms. Everybody wanted to understand what algorithm are using to do anomaly detection, but the market's really moved on and advanced now, where it's about the remediation of these issues and taking it all the way through from fault diagnostic to prescriptive guidance to a case library system that's tracking all of these issues, tying it back to that asset template, so you can search for common problems across your business that maybe you had with that asset or other assets of that same type, and then actually linking it to the information digital twin. So now I can see these early warning alerts in the context of the physical asset itself in 3D in my plant, and do I have any other assets in that part of the plant that maybe I have an early warning condition with as well. And what that really allows me to do is be much more proactive in my maintenance planning across the business.
Yeah, and to piggyback off of that, the truck will tell you before the driver ever knows. And it'll tell you, even in trailers, we're running sensors on the wheel bearings now. That sensor will pick up long before the technician will ever find it, and it will save you that failure.
And then I think, just to add to that answer, because part of your question was around how do you close the loop, how does that model performance and tuning and improvement work? And I think the thing that, from a vendor's perspective, that makes Pepsi such a joy for us to work with is they invested in the cultural changes and the systemic changes required so that we can get these feedback loops that go back into our product. So if you go into a Pepsi shop today, you're going to see a board. That board's going to have every uptake insight into it. It's going to be able to go right into their Infor system like you saw, and that feeds right back into our system. And that takes commitment to do, right? There's people changes, there's system costs to do that. But you see when you get to the end of the journey, when you've made those investments, the performance that I can provide to Pepsi is much larger than somebody who's really gonna, inch along and not take that full leap of faith.
And it's not overnight. We've got 2 years invested in this, and as you saw, we started with 4, now we have 150 models running, and it's only gonna grow from there. It's probably gonna get into the 500 range by the time we get EV and everything else going for us.
Yeah, we have a fleet risk team that's sort of dedicated to closing a loop because it's in 3 phases, right? One, either a fault occurs or you capture the fault. Then the second is documenting what the criteria is to see if it's going to happen again. And then the third is what remediation do you have? Well, I guess it's 4 because what remediation do you have for the current fleet, and then how do we prevent it? So the first phase is, figuring out what those limits are, figuring out what that model looks like, and then alerting if it happens in the fleet. But then you want to get to the point where you're preventing a model from ever alerting in the first place, right? So then that's where the fleet risk comes into play, where they can do that deep dive, figure out what that fault is, what the remediation is. That team used to spend time trying to figure out their criteria and developing the model and doing that piece. Now they focus mostly on the remediation portion. What new coding do I have? What design change do I need to make? Which was really important to us because the less time they spend on this piece, which is covered by the software that we've created, or they have one model they make and they can deploy it across the fleet instantaneously, essentially, then they can focus on closing out that loop. But essentially, to answer your question, is we have a fleet risk team that is tracking all of that, creating a case library, and then uploading these into a diagnostic reasoner or machine learning library, case library. There's a bunch of different names to it. But.
One other point I wanted to make about the challenge when you are identifying, you've got these systems that are creating a lot of punch lists and work orders for maintenance activity. You must budget for the actual maintenance activity that's required to get them to prevent some of these problems. Just identifying the problems and creating long work lists, all of a sudden you're becoming the enemy of the maintenance department because they can't keep up with the amount of work that you're generating. So let's make sure that you've got a long-term strategic commitment, enterprise commitment to finance the work that's going to be to get to that point where you are doing proactive as opposed to reactive maintenance. And they're clapping for me. Why aren't you?
They didn't like you, they did.
Yeah, one more point to make there is you have to understand your business.
Yeah.
So we've got a 2-year commitment into this already. When we started this, we thought we were pretty good until we started looking at our reliability numbers. So industry standard is 2 to 3 breakdowns per 100,000 miles or 1 year, whichever comes first. We were running 5, 6. We've spent a lot of money, as they mentioned, to get down to where we need to be because you're going to put that money up front as you're fixing assets. But our latest numbers today, we're running 0.98, so we're leading the industry in reliability, which is exactly what you want from the product.
Very nice. I believe we have a question up front.
Can you give us more information and explain what's required in terms of skill set and experience to implement the solutions and then sustain them over maybe the 20 years that the owner's gonna have them and keeping them up to date?
I'll take it. So we have a lot of users. I'll use one user, Nippon Gases in Belgium, and they manage these air compressors for their customers and everything. I thought they were going to hire more people, and they didn't. They thought this was just an evolution of a very sophisticated predictive maintenance program type of thing. Key point, number one is process engineer who's totally invested in this to make it work in their company. I think the second thing is that they have no interest in building AI models themselves, right? And one of the things that happened with our users was they asked us to build the AI models, which, okay, I knew we had to do that. By the way, I used to run product development for Autodesk. I built an AutoCAD, I gave it to you, never had to deal with anything. That was an easy business. We had to build AI models. But our customers are all asking us for the same thing, managed services. In fact, Patrice, you're a managed service, right? You are a managed service. So to expect to go on your own with this anytime soon is not going to happen. We built a digital twin studio, citizen data scientist, model builder that your engineers can use also. But everyone has a full-time day job, and now you're adding something to it. So I would say, what do you need? It could be an uptake, it could be anyone, but a partner in this journey, right? Buying software is a disaster, right? You need a partner in the journey, and that partner is not going to go away very quickly. Your people will take it. Actually, Vijay and I talked about the social aspects of it. Have dinners together, right? and then your partners. But kind of that's my experience is we never thought we'd be in managed services. Every one of our customers are asking us for managed services that they can see anomalies. They're smart people also. We always do causes and recommendations, but yet they want just a little bit of a backstop.
Yeah, and I think to add to that, I think the conversation even a couple of years ago was, do I invest in technology or do I invest in my people? And the answer is you have to do both. Even if you were to invest in technology, if the people don't know how to use that technology, it's going to be useless, right? So even if you have a managed service, okay, well, this is spitting out this recommendation, but is that something we want to roll out to the fleet? Somebody has to be knowledgeable. And to answer that question, what skill set you need, honestly, the skill set is to just be invested, because we have operators who were operating a plant for 50 years, and they're, 5 years away from retirement. They're reviewing the same data as an engineer that just came out of college. And if they're invested in understanding the benefit, we haven't seen that big of a hurdle in adopting the technology. They're not necessarily building the models. That's more what the senior engineers are doing. Mm-hmm. But understanding the outputs of the data and utilizing the tools hasn't been that difficult.
To continue on this thing, if you look at our team working on a weekly call with the vendor, you can't tell who's from Logan and who's from Azima Symphony, because they learned about our process, we learned about, so there's the translation of the black box to the white box, and the information going back from our process folks when they communicate with our AI. So they're practically our data science part of our team. When you look at the weekly calls, you can't tell who's who.
And I'll just add to that it's getting a lot easier. We've been doing this for a decade, and so the templates are there. We've modeled hundreds of different pieces of equipment. We've built the fault diagnostic libraries, the prescriptive actions that go along with that, and really have built it in a way that you can build model templates. And if you have like assets across your business, maybe they're slightly different. They're different manufactured, they have different sensors based on their age, based on the configuration. But you can leverage these model templates to deploy very rapidly across a fleet of assets.
There's only one problem with that.
Mm-hmm.
You go to 8 plants, you have 8 different sets of individuals who react differently and get you the data you need or build the models a lot differently. So everyone has templates, but it's just not so simple. It's just not so simple.
Yeah, I think as you start to centralize your operation, you've got to get to some level of standardization within the business. Otherwise, it just gets too difficult to manage. We've seen customers where they had different KPIs in the way they measured those KPIs at each site. Yeah. And that's a really difficult thing. So the more that you can bring this up to that top layer, do things in a consistent way across the sites, apply best practices, the better results I think you'll get.
Yeah. That's exactly what we're using it for, is to standardize the diagnosis and standardize the repair.
So I do have a lot of passion around standards. I was working for the USPI Standards Organization Process Industry for 3D models, facility lifecycle 3D models for the past year. And one of the things I found is there's a lot of people in the innovation space that really don't like being boxed into the constraints of someone's idea of what is the standard, because now I have to only can innovate inside the box. I can't think outside the box. So it's really got a conflict there. If you're really going to be autonomous and allow your people to think creatively, you can't necessarily constrain them. So it's a balance between that, and really look at those things as not necessarily competing goals. It's really more, we're setting guardrails for you to operate within. But make sure that you're setting those standards in such a way that there is interoperability. It's not giving one vendor a proprietary advantage because they happen to be on the standards board. It's making sure that we're looking at what's best for the industry, where it's going. And I think that, to your point about a 20-year life cycle, you can't make a standard that's going to necessarily think about what life's going to be at the 20th year. You've got to make sure that your standards are adopting as well. And it takes 2 to 3 years to get a standard out if you got agreement within the industry that this is what they're willing to accept. So that's really hard, because by the time they agree on a standard, it's probably obsolete. So that's what I've been experiencing, and it's one of the things I'm challenged with is how do I go out there and promote standards at the same time promote innovation? Those almost seem like they're conflicts. But to your point about growing a plan that's going to get you be able to manage that 20-year life cycle, that asset, 40-year life cycle, some of the assets we're dealing with, you've got to realize that life cycle is going to have different missions throughout its, that asset's going to have different missions throughout its life cycle in order to achieve what its customers are demanding, because that's really what this thing needs to do.
I think the standards that are most important, the standards in work processes, which you agree and then you can change as your solutions mature.
Yeah, your provider has to be fluid because your KPIs will change, your assets will change, your technicians will change, and it could be a capability thing. But if,
You have to go back into the applications and make changes there. Is that easy or is that hard?
for us, it's been easy.
For us, I would say easy because we don't do it, they do it.
Exactly.
Nobody's gonna say it's hard.
The answer to that, I think both sides of it has truth to it. If you have hundreds and thousands of assets that are similar in certain way, either like PepsiCo or Mitsubishi, standards and repetitive, so that works in there. We have 4 slitters, slitting aluminum sheet. So Azima, the Symphony thought, oh, we can repeat the model. No, each of the 4 slitters failed differently because they're all 40-year-old machines and they're like individuals. We all talk differently, right? So the slitters fail differently. So in that case, we need more hand-holding. In examples of Mitsubishi and PepsiCo, where they have thousands of assets, they can standardize and reuse the models and bring standards that they can make the life easy for them, except for when the KPI business changes.
Yeah.
Yeah, and there's two different, it depends on the vendor or the partner that you're working with, right? Because there's 2 different aspects. One, they hand it over to you and you can do whatever you want with it. And then there's other vendors that it's theirs and you have to provide the feedback to them for them to input it. So it just depends on the kind of relationship that you want and how much control you want over that information.
We are not smart enough to use their system, so we don't buy anything that won't come with a managed services. We know how to make aluminum sheet and not let it leak in your hand, but we don't know all that.
Well, I have another question for y'all. It seems that a lot of AI projects get into this purgatory. So if I'm doing APM, how do I make sure my project doesn't get into this purgatory? This endless hole, this loop.
Yeah, I mean, pilot purgatory is a term that's used fairly widely in the industry, and it seems to be very much used in the context of applying AI and ML for asset health and performance monitoring. I would say that, one of the challenges I see is that if you kind of take the approach that, look, I'm going to take this technology, I'm going to apply it, and I'm going to see what it does for my business, a lot of times that's not successful. Is if you first take a step back and you look at, okay, this is proven technology in the industry. It's been there for a decade, no doubt. I can apply to reduce failures, improve the reliability of my assets, the performance of my assets. And so really building a business value case from the inside out of what is the value of implementing this technology across my business at scale, not for a pilot, and really justifying this from a business case perspective before you even look at technology. And then once you figured out what the opportunity is within the business, then you can start to look at vendors, find out what's important for you from a feature functionality perspective, and then go forward with the goal to deploy at scale.
If I can take it, we're a 56-year-old vibration condition monitoring company. So I like to say vibration is a temperature check. And all of this AI-based stuff is an MRI. And think about in our own lives, when the doctor says you got to go for an MRI, you know what that means, right? First of all, it's a deep analysis and it's expensive, right? So it goes into the criticality of assets. Like Vijay was saying, his assets are pretty critical, right? So number 1 is criticality of assets, number 1. And number 2, do you have, I've had one project fail, one. Disk drive manufacturer, there was 6 tags, right? They gave us 6 tags, we can't help you, right? So is it critical and do you have enough data in it? But if one other potential customer asks me to do a POC on a chiller, I'll throw up. It's like, come on, we're way past that.
Do we have any other questions from the audience? Okay.
Time for the beach.
Yeah.
Fair enough. It might actually be.
One in the back.
But I mean, is
One
it
in the
as simple? Oh, okay.
we do have a question.
So we've been hearing a lot about, the coming big disruptor of sustainability and energy transition and decarbonization. And when it comes to asset management, I wonder if you could comment, does that mean you're just going to all keep doing what you're doing just a little harder? Is it going to be something radically different? Is it going to be a core focus area for your companies? How should we think about this?
In a manufacturing shop floor where you're doing somebody like us in a factory environment, it's an extension of APM. What we're doing is tracking a lot of data points we track for the asset condition are also important for assets energy consumption, how the asset emissions are. So we look at it as an extension of this, and actually we're having that conversation about APM to Process 360. For manufacturing, it's an extension. For different industries would be different.
In a carbon-intensive industry like the oil and gas industry, which I came from, what I found is that they're having a hard time attracting capital to invest in in new, building more of these sites, systems that would increase their carbon impact. And trying to decarbonize and make them more sustainable is really hard to go shift overnight to the alternatives when the price of the commodity products is right now it's real attractive to go build to grow more. But in order to get that asset to actually survive another 20 years during the transition, you're going to need the digital innovation to understand what's going on inside those assets, so you can better analyze where your failure points are. Because maybe this asset was never intended to operate at this level of demand. A disruption like what's going on in Europe right now with the boycott, or I guess the embargo of oil, is making it very difficult for the prices that are happening is making it very attractive to bring more investment into oil and gas type of carbon intensive areas. That's not necessarily going to achieve the zero carbon goals and objectives. So attracting that you're going to have to make sure the current assets can decarbonize and be sustainable, and you're never going to be able to make those decisions without the innovation and automation that's available through these kinds of tools.
And I'd say that's a really thoughtful question. And the interesting thing is it becomes another value proposition of investing in predictive monitoring of your assets. So traditionally it's been reliability improvements, performance improvements of the asset, but now there's these ESG improvement opportunities, right, that we can leverage the same technology for. And then to take it a step further, it's not just that I have AI and I don't need the physics behind how these assets operate anymore. That physics is still important. We have 30 plus years of process simulation expertise. And what we're able to do is take these first principle physics-based rigorous models of the assets, use that as soft sensor inputs to these predictive AI-driven models to provide more diagnostics, earlier fault detection, and really get the best of both worlds.
What I can say is, if you just sit in this room, nothing's going to happen.
Oh, right.
You go to Europe, and all of the presenters would have started this presentation, what they're doing in terms of getting net zero.
Yeah.
I'm actually shocked in this conference. I've been to a lot of sessions, and there's actually zero discussion about it. Really, so that's a very thoughtful question. It's totally different in Europe. So I won't get into like everything that you talked about, because you're right. It'll just be part of the value proposition for it. And, I think of like the things that our customers do with heat exchanger fouling, right? And I've got all these heat exchangers. What's the optimal schedule and the optimal sequence? And that's just for efficiency and cost, but it could be the same thing for carbon management also. Now, is it going to change everything compared to changing air gas ratios on a furnace type of thing? Not really. And is it going to change things compared to going to wind? Not really. So I would say, I think it's just going to give them a very marginal improvement, frankly speaking, a very marginal improvement. But it'll start to grow in you know, whether it's Aviva uptake or our products, it'll just grow into it naturally.
So Greg, one of the things I think as ARC, what you should be doing, continuing to do is encouraging your clients to look at upskilling and how are we, what are we doing to ensure that we're bringing in the data management. It may have been petroleum data management in the past, but now we can look at it as energy data management and seeing how wind, solar, nuclear, other alternative energies might be, a lot of the lessons learned in the oil and gas industry is going to retire and go away. What are we doing to take the lessons that they've acquired over the past 160 years and apply those to some of these new challenges that we're having? One of the things I've noticed through this class that I just took through Robert Gordon University, where the government is upskilling and paying for and subsidizing people in the, right now currently oil and gas sector in the northern, in Scotland. What they're trying to do is they're trying to make it so that these guys have somewhere to go. These people who are sitting in oil and gas jobs that will go away in the next 20 years, how are they going to transition them into a way that they can make them more sustainable and also take the world with them, in terms of bringing that kind of data management knowledge that we've acquired, the lessons we've learned, apply those in these other industries.
Yeah, I echo that as well, because we have a website called Path to Net Zero.
Mm-hmm.
So it's not something that's an afterthought for our company, and the push really is towards hydrogen and renewables, and what do we do with all that information? I mean, there are certain things that can translate pretty easily, and if we have the faults mapped in the appropriate ways, the machine learning and AI can transition to some of those more sustainable ways for power. So it's definitely on the forefront of what our company is trying to accomplish. I think 2050, 2030, there's a 2030 plan and a 2050 plan, but it's definitely on the list and a priority.
Yeah, our plan is 2030 to be 85% carbon reduced footprint. We've already got net zero plants out in California that are running today, all electric. So from the plant, the manufacturing, the warehouse equipment, all the way to the delivery system is all electric.
All right, any other questions? Okay. I think that's all we have. So I'd like to thank you all for being
Thank you.
present. If anybody has any questions for these fine folks, please see them afterwards. Shoot them an email. And thank you for your time.